this experiment, we shall investigate a capacitive DC circuit using a data logger. For the first experiment, we shall charge and discharge a capacitor through a fixed resistor. We require a capacitive circuit, some wires and connections, a two-way switch, a capacitor, a power supply, a sensor meter for voltage, a data logger, a computer, and finally a screen. This is the circuit diagram showing the connection of the capacitor, the two-way switch, and the supply. We start the experiment by opening the application on the computer. We click on the icon Data Disk AG. Then we click on Measure, followed by Record. And in this window we select Choose Duration and Interval. Duration is 1 minute and interval will be 100 milliseconds. Then we click Go. Now we are ready to use. We simultaneously flick the switch to charge and we click on Record on the computer. We immediately observe that the graph is being plotted in real time as the computer is taking measurements every 100 milliseconds and it continues to take readings for a minute. We observe that the PD is increasing with time until it tends to a maximum voltage across the plates of the capacitor. When the computer is ready, we click Add to this data. And now we change connections to prepare for discharging. So the circuit is changed by connecting the resistance across the capacitor. The diagram shows the circuit appropriately. The resistance is in parallel to the capacitor, a two-way switch, which will first charge up the capacitor and then let the capacitor to discharge. We simultaneously flick the switch to the discharge and click on Record. This is the record icon, and we will see that the discharge curve is being plotted in real time. And we know that the PD now is decreasing with time because the capacitor is discharging through the resistor. The computer continues to take readings every 100 milliseconds for a minute. When ready, we select Keep this data from the left menu. And we can see simultaneously the discharging and discharging curves. We now click on Data followed by Calculate and Smooth, so that we will get smooth lines. We repeat the procedure for the other graph. And we are ready. We will now use the graph in order to read values from the curves by choosing Graph and Cursor on the menus. The cursor changes into a cross. We will then place it on the graph, and we can run the cursor on the graph so we can see the coordinates. We're going to find 0.37 of 4.7 volts. 4.7 volts is the maximum voltage across the plate, and we're going down to read 37% of the maximum voltage. And we read that 1.74 corresponds to 7.9 seconds. This is called the time constant. We repeat the procedure for the charging graph, but in this case we're going to read the voltage when it is 63%. So we go for 2.96 voltage on the charging curve. And this corresponds to a time of 7.7 seconds. This is again the time constant of the circuit. Here we have the results for the discharging curve and for the charging curve. We obtain another value for the time constant by working out the product of resistance and capacitance, and we find that the three values are very close to each other. In this part of the experiment, we are going to discharge the capacitor through a different set of resistances. For this experiment, we require an electrical circuit, which includes the same capacitor, some connections, the two-way switch, the resistance box, a power supply, the sensor meter for voltage, the data logger, the computer, and finally the screen. This is the circuit diagram showing the capacitor connected in parallel to the resistance box and the supply. We now open the application and click on Measure followed by Record. We then select Choose Duration and Interval to set the values for the duration as 30 seconds and the interval to be 100 milliseconds. We then click Go. We then select 1 kilo ohm on the resistance box, and simultaneously we flick the switch to discharge and click on Record on the application. we observe the graph plotted in real time as the potential difference across the plates of the capacitor decreases with time. We repeat the experiment for other different values of resistances. We select another resistance from the resistance box, and we repeat the procedure by simultaneously flicking the switch to discharge, and at the same time we click on the record icon. And we observe the potential difference across the capacitor decreasing with time. We select Add to this data from the left menu. Finally, we shall obtain a family of curves, each for every resistance we have chosen, and we note that the potential difference across the plates of the capacitor decreases rapidly when the resistance is small, and the potential difference decreases slowly when the resistance is large.